So, hello everyone. We are now live, and this is the third panel discussion of the meeting. It's entitled Consciousness and Representation in Brains and Machines, and I'm really super excited to be co-hosting this with Lucia Melloni, who you see down here. So Lucia Melloni is a group leader at the Max Planck Institute for Brain Research in Frankfurt, in Germany, and her research centers on consciousness, electrophysiology, meditation, perceptual learning, and predictive coding. And as you can see here, I'm joined by Yoshua, Bengio, Alison, Gopnik, and Anil, Seth. We will have a brief introduction to the panelists, but before we do so, I'm just going to give you a very brief overview of the scope of this panel and what we had in mind. Of course, we might go in all different directions, and that's perfectly fine, but at least I'm going to share with you another good news before I do that. I'm going to tell you that Dennett has just joined, so he should be appearing on screen soon. So that's we were waiting for Dan, so it should happen in a few seconds. Yeah, I'll tell you about the scope. The goal of the panel is to have an inspiring, hopefully, discussion on the topic of consciousness and representation in brains and machines. And so the idea is that, hello, Dan.
Hello.
Very happy you made it. So the audience will have hopefully the chance to hear different perspectives from world-leading scientists in developmental psychology, neuroscience, philosophy, and artificial intelligence on the question of consciousness. The central questions will broadly focus on the following themes. How can our understanding of consciousness be beneficial in the quest for better AI? How can AI research help neuroscientists, psychologists, and potentially philosophers in their quest to elucidate the mystery of consciousness and the mind? And finally, why does all of this matter to us as individuals and as a society? Why would we want to do this? So without any further ado, I'll hand it over now to Lucia, who is just going to give us a brief introduction to the panelists that you have on screen in front of you.
So it's my great pleasure to have this fantastic, four panelists, and I'm going to just give you a little bit of few hints as to who they are. I hope that you know them already, and if you don't, I'll just give you the highlights. So let me start first with Yoshua Bengio. He's a full professor at the University of Montréal. I'm the founder and scientific director of Mila. Dr. Bengio is most known for his pioneer work in deep learning, and this earned him in 2018 the Turing Award, the Nobel Prize of Computing, with Jeff Hinton and Jan LeCun. And in addition to his long-term research goal of understanding the mechanism giving rise to intelligence, he has strong interest in using AI for social good, including healthcare and the environment. Our next panelist is Dennett, who just joined us, luckily. He's the co-director of the Center for Consciousness Studies and professor of philosophy at Tufts University. His research centers in the philosophy of the mind, philosophy of science, philosophy of biology, and he's published a number of topics from atheism to religion to consciousness. And he's also written a number of books, including perhaps the most well-known and acclaimed book, Consciousness Explained, which if you haven't read, you should. He has received numerous prestigious awards, including the Erasmus Prize in 2012. Alison Gopnik, our next panelist, you already heard her. She gave us a fantastic talk just before and gave us a fantastic primer. She's a professor of psychology and an accredited professor of philosophy at the University of California at Berkeley. She's a world leader in cognitive science, particularly in the study of children's learning and development, and is famous for her work showing that children think and learn much the way science does. And she's also published a number of books, and I will just highlight one, which is my favorite, The Philosophical Baby, What Children's Mind Tell Us About Love, Truth, and the Meaning of Life. But she has many more. I just picked my favorite. Anil Seth, our last panelist, he's a professor of cognitive and computational neuroscience at the University of Sussex and the co-director of the Sussex Center for Conscious Science. He's also co-director of the Canadian Institute for Advanced Research Program on Brain, Mind, and Consciousness, and also the editor-in-chief of the Journal of Neuroscience and Consciousness. His research pursues many areas of cognitive neuroscience, computational neuroscience, and consciousness. He's done a lot of stuff, including measuring emergence in neural systems, not a small feat, and developing computational models to investigate perceptual phenomenology. He's also the author of a newly published book, very much acclaimed, entitled Being You, A New Science of Consciousness. And this book has been the Sunday Times bestseller, a Financial Times Science Book of the Year, Guardian Book of the Week. If you haven't read it, so good. So that's all from me now. And then I hand it to you, Karim.
Oh, that's the book. Oh, that was too quick.
Very subtle. Very subtle. I got there you go. That's all the marketing I'm going to do.
So the way we thought about doing this is we're going to first start with an introductory question to each one of the panelists, and then we will be asking open questions to all the panelists, and then we'll be taking questions from the audience. So this is a reminder to everybody that is following us to ask your questions in the Q&A and upvote questions that you find most interesting so that we can pick from them at the end. So now I'm going to start with the very first question, and this one is to Yoshua. And so what I'm going to ask you is, as an AI scientist who is a strong advocate for the idea of integrating higher order cognitive functions, thought to be assumed with consciousness, thought to be associated with consciousness, into artificial agents. So as such an AI researcher, can you explain to us why you think this is needed? And are we already at a stage where we know how to do that, incorporate those functions into machines?
Right. This is a great question. I think that we don't ask often enough, like the why. Like, why do we? Why has evolution put more consciousness in us, maybe than in other species, or maybe we're the only ones. We don't know. And I think it has to do with intelligence. In other words, it gives us some advantage in our ability to adapt, to make sense of the world, take the right decisions. And in particular, one aspect, and I think there may be several aspects of this, because as Alison was saying, consciousness is many things. But one aspect I've been focusing on is the ability to adapt quickly to changes in distribution, to non-stationarities in the world, to new settings, new environments, and so on. And why is it related to consciousness? Because if you organize, it's connected to the global workspace theory. And the global workspace theory tells us that we're somehow organizing our knowledge into smaller pieces, the modules, the experts, and we're dynamically deciding which ones are relevant and how to combine them in a compositional way, because our thoughts are really compositional. So that part, which I also call, use the word system 2, of sort of this ability to reason and to compose pieces of knowledge dynamically, and also adapt them, like change them on the fly, imagining new configurations of these that may be very different from the things, the ideas we had before. These are all connected with things we know humans do when they're faced with new settings, new environments, where instead of going for their habits, they have to think, they have to keep in mind consciously, say, new rules that they have to deal with if in a country where the traffic laws are different. So in summary, the ability to model the world in this factorized way, which we see in causal reasoning, and the ability to modify these pieces and combine them on the fly with something that's essentially an imagination machine, probably gives us great advantages in terms of adaptability and fast generalization, as well as abstract representations of things that allow us to plan and to seek knowledge that is most interesting to us.
Thanks, Joshua. And to the second part of my question was, do you think we're already at a stage where we know how to implement those things into our architectures, our algorithms?
Well, I'm not going to say either yes or no, obviously.
Trick question.
We are at first, we don't know how to do it, and that's why we're doing research. But I feel like we now have a bunch of tools, in particular new ones that I'm very excited about, called GFlow nets, that can help us on that path. So I think we are at a time when we can use deep learning machinery, so like neural nets, that can manipulate the kind of data structures that would be a good way to represent what we have in our thoughts, that are not like the standard vectors we have in neural nets, but they're more like sets and graphs that can be dynamically modified and constructed. And so I'm very hopeful we can make a lot of progress in causal discovery and reasoning and out of distribution generalization using these kinds of tools.
Okay, thank you so much. I'll hand it over to Lucia to ask a question.
Let me turn to Dan now, because I think we already heard from Yoshua a little bit of this question, but I want to now turn to the philosopher in the audience and ask him, is there something or anything to be gained by incorporating knowledge about consciousness into machines? From your point of view?
I'm sorry, say that again. Speak a little louder, please.
Yes. Is there something to be gained from your perspective by incorporating knowledge about consciousness into machines? And conversely,
yes.
Let me ask you, because it has two parts, And conversely, what do you think AI research can bring to the table in the endeavor to tackle the mystery of consciousness? So both ways. So what can we...
Well, just to be provocative, I'll say that, no, I think maybe we should keep consciousness out of machines. We could do it. That's certainly possible, but there's good reasons not to do it. Because if we really got the architecture of human consciousness into a machine, then it would become an autonomous agent. And the first thing it would do was try to figure out how to keep us from turning it off or bossing it around. That's because that's what you would do if you found you were under the control of a bunch of other agents. I think my motto for this is we want smart machines, not artificial colleagues. And I think adding consciousness to a computer is asking for trouble. Possible, but not a good idea. And let me add to that too. I think we should not abandon or overlook the possibility that consciousness in us is a sort of two-edged sword, a sort of burden. As Yoshua says, it gives us the opportunity to learn quickly all kinds of new things. I mean, somebody can whisper a little hint in my ear and I can completely change how I deal with the situation because I know language. Ray Jackendorf loves to make the point, often has made the point that you can train a human subject in a psychic experiment in a minute or two, give them a few test trials, and they've got this little virtual machine in their head that can follow those directions perfectly. It might take thousands of trials to do that with a monkey or a dog or a cat. That learning, that training, that no other species but us can engage in that swift learning. And that's a tremendous advantage, but it may also be a hindrance. It may be that that's what puts us in, you might say, Hamlet's predicament. Too much reflection can bring you to a standstill and baffle you and leave you pondering issues which, quite frankly, very often are fruitless issues and are based on misconceptions. My favorite example of that is David Chalmers' hard problem. It's just not a problem, at least as he has stated it.
So do I take it right that from your point of view, intelligence does not require consciousness per se?
I'm still having trouble with you.
Do I take it right that intelligence and consciousness for you are not one and the same? No, you cannot hear me?
I don't see a place to turn my volume up on this.
Oh, that's better.
On this crowdsource thing. I'm having trouble hearing you. Go to somebody else and I'll look around for a volume button.
It might be better now that Lucia has put her earphones.
You want to try again? volume all the way up.
Okay, so I think we'll make sure that the sound improves. I think we'll move on to the next question. And this is a question addressed to Alison. So children, as you nicely showed us in your keynote lecture, are able to learn and perform tasks that some of our most amazing advanced AI algorithms are still not able to accomplish. And so how can the knowledge of how children learn, and in particular, we talked about exploration, but it's also this idea that children like to play and have fun. Should we consider that we should try and let our algorithms have fun and play games and enjoy and find a way to incorporate it into the algorithms to ensure maybe some form of learning that we're still missing right now?
Yeah, I mean, I think that's part of what we're already seeing in some of the examples that I gave before. And I want to say there's an interesting sort of tripartite division about the kinds of things that we do. So there are clearly some kinds of learning that are really completely unconscious, like habitual learning. I think probably a lot of the kind of RL learning that we do in everyday life is unconscious. And then we have the kinds of things that Yoshua was talking about, where we, can sit down, or Dan was talking about, where we have a linguistic representation, we are making particular kinds of inferences from that representation. But I think when you look at kids, one of the interesting things is you see this kind of learning that doesn't really seem to fit either of those examples. It's not unconscious at all. I mean, if you watch a kid who's exploring our Blicket detector, they're completely focused and conscious and talking about what's going on and understanding it, but they're also not articulating it as if it was as if what they were doing was just taking these compositional pieces and moving them around. And I think that, the point of my talk is that's a really interesting intermediate space if you think about things like play or fun or creativity. And creativity is, I don't know if anyone watched the marvelous Beatles documentary over the last couple of days, but that's really a wonderful example with adults where you see a bunch of what looks like very kind of random, disorganized noodling around. Paul is sitting there and just doing what look like very random things on the guitar, and then suddenly, Get Back appears as a song. Now, I don't think that's unconscious, but I think it's very different from the kinds of things that would be happening if you were, say, sitting down and trying to solve a mathematics problem, or if you were sitting down and trying to do something more specific. So I think there's this really interesting kind of third way that we could point to. And I think more and more people are trying to do things like think about games, fun, curiosity as reward mechanisms. But again, like if you just translate curiosity into information game, that doesn't really seem to capture it. And how is it that you know when you're playing? And again, it's amazing looking at those Beatles documentaries. How do you know when it's just random nonsense, right? Where Paul is saying, okay, let's stop. We have to get some songs written, versus when it's the random nonsense that's actually going to lead to the great songs. And if we could see how that happens, we've been doing some work on creative foraging. There's a really nice paradigm that Yuval Levine has for doing this, to try and see how that might instantiate the things that we need in AI. But if you look at all the restrictions in AI, like the lack of generalizability, the lack of robustness, the inability to deal with out of distribution examples, I think Yoshua was right that once you know about something, doing this kind of conscious manipulation is a way of solving those problems. But before you actually have the inferences, before you have the graphs, how do you actually solve the problem of figuring out what it is that you think those graphs are? And that, my intuition is that things like games and fun are going to play a big role in that.
They probably increase also the presence of serendipity, and just because you're actively interacting with the universe in a creative way, and so ideas come up, then you can build upon, which you might have not had otherwise. What about the other direction? How can AI potentially in the future years, how do you see AI being useful as a tool to better understand the developing mind and developmental psychology? Is there anything you see?
The history of, it's sort of funny because, we're always a bit discouraged about the history of cognitive science, but I think the history of cognitive science as a project that is about getting computational accounts of behavior and psychology and finding their neural instantiations, I think it's been an incredible success. I mean, there's much more success than there is failure. Of course, we pay attention to the limitations because that's where we want to do the work. But if you look at something like vision science, for example, we have really beautiful accounts that integrate phenomenology, behavior, computation, neuroscience. And I think in developmental psychology, there's developmental psychology and cognitive development in particular is another really nice example of that, where, back in the aughts, people like Clark Gleamore and Judea Pearl were trying to do work on causal discovery, and absolutely in parallel, people in developmental psychology were doing work showing what was going on with children. And the Bayesian revolution in cognitive science is another example where that was driven both from the computational and the exploratory side. So I think we've already shown that project of let's figure out what the computations are, how they're related to the phenomenology and behavior, and how they're instantiated neurally. I think developmental psychology is actually an area where that's been working really well.
Right. Okay, thank you so much. Maybe Lucia, you're going next question with Anil. You're muted. Let me just unmute you. See if I can unmute you here. Try again.
Oh, this is going to be a hard question to answer. Yeah, nothing's coming through, Lucia. I'm sorry. The answer is 3. I mean, do you have the question, Karim? Maybe you could ask it. I don't know.
42, yeah.
Okay, so Lucia, if you can hear us, maybe you need to remove this time the headset again. Maybe your audio will come back. I will read the question out.
Okay.
Unless we can hear you now, but I guess we can still can't hear you, Lucia. No.
She's muted still.
Yeah, you're muted, so your sound is not there. I'll ask the question in the interest of time. I know also that both Dan and Anil need to leave pretty soon. So the question we had for you is, well, we know that you've said a number of times, Anil, that you absolutely think that we should not seek to build sentient or conscious machines. And the question is, do you think it would be theoretically possible in the first place, irrespective of whether we should or we shouldn't? It would be interesting for us to know whether that's something that you think is theoretically, not theoretically, practically feasible. Would you be curious to know what you think about that?
Yeah, thanks. That's a good question, Karim and Lucia. I mean, the short answer is yes. It is definitely theoretically possible, but it depends on what you mean by machine. I mean, we're all machines. We're biological machines. We're conscious. You have a baby. You've built a new conscious machine. I think that the question that most people have in mind there is, could something that is built out of a different kind of stuff, whether it's the kind of computers that we have now or near future computers programmed in a particular way, could they be conscious? And here, I think there's a very reasonable argument to remain agnostic, because one of the big assumptions underlying all this is that some form of functionalism is true, that it doesn't matter what the system is made out of, it matters kind of what it does. And that consciousness is some function of information processing of the right form. And I think that's just up for grabs. I don't see a good reason to strongly believe it a priori to be the case or to deny it a priori to be the case. And then you have a whole kind of range of different theories of consciousness, and they will all say different things about what the sufficient conditions for consciousness are. Like if you have something like integrated information theory, it will say, yes, you can build a conscious machine out of basically anything, and it doesn't take that much. It's not going to be conscious of very much, but it's a property of the cause-effect structure of the system. Global workspace theory, as Yoshua said, makes a different set of claims about the sufficient basis of consciousness in terms of ignition and broadcast, and so on, and so on. And so I just worry that, in my view, I've sort of got closer to the view that consciousness, at least in humans, is more intimately tied with the mechanisms of life, of the regulation of our bodies as living systems, with no bright line between our kind of mindware and wetware, in the same way that you have a bright line between hardware and software in most, at least current computers. And from that perspective, it follows that maybe you'd have to have a living machine to have a conscious machine. So that's the answer to the first one. It really depends what kind of machine. I'm much more worried about consciousness in brain organoids, for instance, than I am in the next generation MacBook.
Right.
But why I think we shouldn't do it, and let me just return that very briefly, is like, why do people make an argument that we should just go ahead and build a conscious machine? It's usually because it seems cool or science fiction-y or some way. Yoshua and I have had a number of conversations where we're talking about the many benefits of building machines that have the functions associated with consciousness, and Yoshua and Alison have picked out a couple of those already. Why shouldn't we do it? Well, Dan raised one, but why should we not build a machine that actually has experiences? Dan mentioned one reason, that they might preserve themselves and prevent us from trying to turn them off. There's another more basic reason. As soon as you build a conscious machine, you're building something that has the potential to suffer. And the essence of consciousness for me is not in intelligence or system 2 thinking, although that's part of it, but in the basic preservation of the organism. The most basic form of consciousness I think most organisms have has to do with mood, emotion, the prospect for staying alive. As soon as you build a machine that has the potential for consciousness, it has the potential for suffering, you take a moral stance towards it. That's, for me, a much more basic ethical imperative to not go about it as some kind of objective purely because it's cool.
Yes, I'd like to underline my agreement with Anil on that point. One of the questions that was raised just a few minutes ago concerned whether we know how to build the architecture, the computational architecture for consciousness. I think the answer is we certainly don't yet. And I think that one of the reasons is that so far, every computer that we know how to deal with has something like an operating system. And an operating system is intelligently designed, and its parts work very well and for very good reasons. But the operating system of the human brain is an evolved thing that is partly the result of development from birth on. And I don't think anybody has much of a clue about how to make an open-ended, apparently indefinitely revisable operating system. If you look at earlier systems that like ActStar or SOAR, you see that they had so many nice features, but they were ultimately had a cap on them. There was a rigidity. There were things that could not be undone. They could not be revised ad lib. And I think perhaps one of the amazing things about the architecture of human consciousness is that it seems that it is much more revisable, much more labile, much more plastic than any architecture we've built using a digital computer.
Dan, your sound was going up and down. I don't know if there's a problem with your mic or something.
Yeah, that's better. When you're speaking closer to the mic, that seems to be working better.
Okay, sorry about that.
That's good.
Can you hear me now? No?
Yes.
Yes.
Oh,
you're back. So we can now move on to the second part where we wanted to ask open questions to all four of you. Shall I go, Lucia, or do you want to take the first question?
Let me, because I thought one thing that I was trying to ask Dan, and I think that Anil was trying to talk about that, is if one day we explain all that is concerning to doing, will we also explain being? And so if we do all of the doing in a machine, will consciousness emerge? Because it's a collection of doing, and then suddenly being appear there. So where do you stand there? And I think that I particularly want to push Anil on that, because he entitled his book "Being You and Not Doing You." So I guess he's trying to make a distinction.
We've built airplanes; they fly. they're inspired by birds, but they don't fly the way birds do. And we can build any number of wonderful machines that explore aspects of good theories of human consciousness, but don't do it the way we do it. And I think that's probably the way we should continue to do it, partly because it's so much cheaper and faster. If we get good abstract theories of consciousness, then we can help ourselves to many of the features of human consciousness as we like, without going the whole way. And I think we should resist going the whole way for the reasons that Anil has stressed, in addition to the ones that I've mentioned before.
I think
By
just
the way, I'm going to have to leave in about 5 minutes. Sorry about that.
I like the way you put it, Lucia. That is being just the sum total of doings. And I mean, for me, that's another way of phrasing, is functionalism the case or not? Once you've expressed what everything does, is there anything left? Is left anything over? I think another way to put it is like, you can write down a sort of formal description of what you think the sufficient mechanisms are, and what animates that. What, to use the words of, like, I've forgotten who, what breathes fire into the equations? Is it information processing? Is it just having a certain sort of collection of doings? Or is it something that is more substrate dependent in some way? And I'm not really trying to come down hard on one side or the other here, but just to leave the question, I think, interestingly open. I mean, we know there are some things for which the sum of doings is not the same thing as being. You have a classic example. You have a simulation of a weather system. It does not get windy. It does not get wet. Rain is substrate dependent. Playing chess is substrate independent. Machines play, or they play the history of chess rather than chess, but the sum of doings is being in that case. For us, it's just not clear to me, and I think there's good positive reasons to think, because of the way our conscious experiences seem to be shaped by this imperative for physiological preservation, that just simulation of all these processes might not breathe fire into the equations. We might need to actually have to be alive. But that is not a logical deduction from these arguments. It's more just, think, a question that remains open.
I'd like to strongly argue against what you're saying, Anil.
That's why we love discussion, you see?
Yeah, so of course, nobody knows if the functionalist hypothesis is true, but there's a lot of evidence in favor. You talk about this fire and you talk about life, and it makes me think like you're still talking about the way where people were thinking about life in 3 centuries ago. I feel like the fire you're talking about, it comes already in modern reinforcement learning systems. The fire is, you have a reward function, and it may be learned or it may be evolved in part and whatever, but that's the motivation part. And it pushes artificial agents in ways that may seem very similar to how living agents go after whatever, food, knowledge. So that's one piece of evidence. The other piece is everything we've constructed in science is essentially built on the functionalist, what you call the functionalist hypothesis. We're breaking down knowledge into different abstractions that are, maybe at different levels. Think about going from the low-level chemistry of what's going on in a cell to what's going on, in our mind. And we are able to make sense to some extent about the world, thanks to that separation of levels. Of course, in the real world, there's always some linkages between those things, but we can understand, like the causal mechanisms, for example, the scientific theories, without having to refer to everything that's below and everything that's above.
Yeah. I'm sorry, I don't want to dominate, but you're just taking, you're using functionalism there as a sort of epistemic strategy, right? That's true. Yeah, we use it to figure out how things work, but chemistry is all about figuring out the properties of substrates. It is almost a study of what kinds of things substrates are capable of. And I'm not thinking about life in this sort of spirit vitalistic tradition, almost the opposite. That I think if we apply the same lesson of how vitalism dissolved to consciousness, much as Alison was saying, that consciousness is not one thing, it's many things, then this mystery that we think is there may well dissolve as well, as I think Dan argues. So I'm not sure we can disagree as much as you think, but I'll leave that to others.
There's a really interesting point, which I think people, I've always wanted to write a paper about this, which I think people neglect, which is when we're thinking about functionalism, think about the history of cognitive science. As often as not, the functionalism was informed by phenomenology. So if you think about something like vision science, which is by far the best advanced case, if we didn't have phenomenology, we wouldn't be able to do vision science. What we do in vision science is take things that start out being phenomenological, like the color space, for example, right? That starts out from a bunch of things that we know about phenomenology, or the fact that you have closure in a Gestalt perception. And then we took those things and adapted them as accounts of what the underlying function was. I mean, another classic example is in fact, computation itself. This I think is really interesting. Think about Turing discovering computation. Where does the idea of computation come from? Well, it comes from a bunch of women who are sitting in Bletchley Park, internally, consciously saying, to themselves, okay, now I'm going to move this code over here and I'm going to move that code over there. And the great thing that Turing does is to take that conscious phenomenology of doing a computation, literally doing a computation, as in the women in Bletchley Park doing computations who were the original computers, and then saying, how about if we use that in a different context? How about if we work out what the functional consequences of that phenomenology are? So I think often when we talk about functionalism, we act as if there's this thing, function, which we kind of discover independently of phenomenology, and then there's this problem about how we reintegrate the phenomenology. And I think actually what happens is that we go back and forth between phenomenological information, functional information, neural information, and that as in the vitalist case, that is going to be the path. I mean, not only is that going to be the path, but that has been the path that's actually allowed us to
if I can get in a parting shot, because I have to leave in a minute. I wanted to just expand on something that Alison just said. Yes, functionalism is the way of doing science, but another part of the way of doing science is to go for the low-hanging fruit first. That is, try for a simpler theory rather than a more complex one. And you never know how far down you're going to have to model to get what you're looking for. Sometimes you get it at a very high level. Yippee, you get progress. You get a sort of an existence proof. Look, this simple computation will do the following thing. We don't have to go any deeper than this. Other times it looks like we have to go all the way down into the physics of the body and maybe even into the chemistry of the body. But you don't start there. You start optimistically with the what's the simplest possible model that might do this job. And if you find one, you've learned something important. And on that note, I'm going to have to thank you all. It's been very interesting, but I've got I had my calendar wrong, and now I have to go and do a Zoom meeting. So,
thank you so much.
Bye, Dan.
Bye, Dan. Nice to see you.
Thank you so much. Okay, so with that, we'll move on to the next question. So this is a question related, this is a question to everybody. So the emergent theory of consciousness proposes that consciousness arises as an emergent property, right, from the complexity of the brain. And so in other words, is there any risk that consciousness could potentially emerge, even if that was not the intent, if we keep on adding functions that are associated with consciousness into these machines as a result of this emergence? So could that emerge? And in that case, what are the risks and what are the ethical responsibilities or legal issues that could follow up from that? This is close to a question we had with Anil before. Anil, you want to go? Looks like you, yeah.
Actually, I just wanted to clarify something about that question which confused me, because there are two different senses of emergence that you're using.
Yes.
There's a sort of emergence over time, which we usually think of as diachronic emergence. So, things get added, things of like evolution as the emergence of biological functions over time. There's also a kind of synchronic emergence, like you have emergence that couples different levels of description, much as a flock of birds is said to be emergent from the individual birds that make it up, even though the behavior of both the birds and the flock is stationary over time. So I wouldn't want to conflate these two things here. I think there's a lot of interesting questions that can be asked about, does it make sense to describe consciousness as a synchronically emergent property? And I think if you are non-spooky about this and take a view that, yes, consciousness has some sort of global properties, like we have unified conscious experiences that somehow depend on distributed mechanisms, that's very useful, and we should develop quantitative measures of emergence. We're doing that with people in my group. But that's separate from saying, if you keep adding things, does consciousness then glimmer into existence? And here I think there's this slightly odd idea that as systems get more and more intelligent in AI, that consciousness will just come along for the ride. And I don't see a justification for thinking that way.
Yes, no, that was not definitely the sense of the question. That would be true if we're looking at continual learning and we're adding on things as we go along. The idea would be in our ability to add more things and have them co-activate and start synchronously at the same time. So that's it's more like the second one.
There are quite a few people in the AI community who think that super intelligence and consciousness and all that are going to emerge just by making our current neural nets bigger and bigger with like looking at GPT-X and how good they are. And of course we don't know, but my sense is this is very unlikely to happen, because I believe that you need some sort of principle that we're missing, and we have lots of evidence that even these very large networks fail in qualitative ways that are very different from the way humans fail. And of course, if you look at the evolutionary scale, I mean, something like our consciousness emerged, but that was a guided search, because it had survival value and eventually converged to something that helps us a lot. But I don't think it emerges just by having a bigger brain, for example.
Yeah, I mean, I think there's, of course, this is all very speculative, but a book I'd highly recommend is Peter Godfrey Smith's Metazoa, which is about trying to, among other things, about trying to look at the history, look at the actual evolutionary history and get some ideas about, what kinds of changes in organisms might be associated with consciousness. And I think a lot of people have made the argument that something like the Cambrian explosion, where you start having sensors and actors, and the sensors and actors are interacting with one another, and they're valenced because you want to get away from prey and predators. As Anil said, that seems like the kind of systematic properties, rather than say having a self-consciousness or just having a larger data set, or being more intelligent in the ways that we often think about it, having a global workspace. It seems like those things might be more related to just sentience. But that does raise the question about, if you wanted to have really functional AIs, they, especially if you're thinking about robotics, right? You'd want the robots to be able to do exactly the sort of things that brine shrimp can do, like taking a lot of data and combining it in a central way in a way that allows you to make judgments about what's good for you and what's bad for you, which is something that they're not doing now. But it could be that if you tried to develop a robot brine shrimp, it would start doing things that without your intending it, it could start out having something that looked more like consciousness. I think this idea of interacting with the environment around you genuinely, Jablonka and Ginsberg make exactly that argument. So Peter and I've talked about this. Peter and Ava both make that kind of argument, and other people too.
Right.
I'd like to go back to the social and temporal aspect of emergence that you had in your question, Karim.
Yep.
So I think it's a different subject, as Anil pointed out, but it is a worrisome one. It's not that, I think, first of all, I think there's a kind of something that bothers me in the question. I don't think that consciousness or intelligence are binary things that suddenly we discover it and some crazy things happen thereon. It's an accumulation. However, there is something worrisome in that we already know that humans build tools like social networks, for example, without necessarily understanding the consequences of how, what's going to happen when these are deployed. And the consequences could be pretty, sinister. So that's what I'm worried about. And the more powerful the tool, like, the more intelligent and whatever conscious the machines we build in the future, the more the consequences could be terrible. So in that sense, it's, there may be emergence because you have like thousands of companies around the world thinking they're going to make a lot of money by building this super intelligent conscious machines, but bringing into the world something that could be destructive.
Right.
So of course, there's a whole field in AI that worries about that,
Right.
and that thing is important.
So thank you, Yoshua. In the interest of time now, I'm looking at Lucia. Maybe we can just have 2 quick questions and ask the panelists for quick answers so that we can take a few questions from the audience. There have been many, many questions and a lot of discussions that are going on in the chat. Clearly, we won't be able to cover everything, but at least a little bit. So Lucia will give a last question, and me too, and we'll ask you to try and go to the point in your answers, if possible, and then we'll turn to the audience.
So I will pick one that was supposed to be for you, but I like it, so I will just shout.
Go ahead.
Love to play and often learn best when having fun. So how fundamental is this aspect to the process of learning? And should AI algorithms incorporate playtime, or something of that sort?
It's already the case.
Yeah, it's already the case. And we don't know exactly why it works, but I think we have some ideas, and looking at young creatures can give us some more ideas about why that works.
But what are your thoughts on, what are the reasons why that may actually work? Is it just reward? Is it
because you need to gather information? I mean, that was 80% of Alison's talk. That we need that because we don't have a blueprint of how the world works when we're born, and so we have to figure it out.
Yeah, and if you think about the motivational system, again, this is part of the explore-exploit trade-off. The exploit rewards are really obvious, and you sort of need to have you need to have something to keep you from just wanting to exploit all the time. You need to have a motivation of something that feels good and makes you happy, that isn't an exploit reward, in order to be able to have the exploration, because the exploration depends so much on your active interventions in the world.
I guess what I was trying to kind of put in there was the idea of consciousness, right? Because you can think of exploration and exploitation as 2 functions in which, you are curious or not, but this concept of fun, the experience of, might not be there. So what I was trying to kind of put in between is the being, so to speak, as opposed to just the exploring or exploiting. You see what I'm trying to get at? Which is, one is the function that you can think of just being curious or just homing down into one particular landscape, but the fun that we have is perhaps something else.
It's a reward function. That's it.
Mm-hmm.
Okay, I'll take that for a short answer, because we're going to move on to the last question before we turn to the audience. Parts or components of philosophical and scientific knowledge of consciousness that AI scientists, including Yoshua and others, seem to focus on in the quest of incorporating consciousness or the functions thereof into AI models, primarily stem, I would argue, from a Western or a Eurocentric view of consciousness, and potentially excludes other views such as Eastern traditions and indigenous knowledge. And I'm wondering, do you see a problem, or what are the problems moving forward? Specifically, if we are at the stage where we're still figuring this out, it might still be time for us to rethink this and make sure that we do this in the right way.
Can I say something here? Because I'm going to have to go in 2 minutes.
Okay, go ahead.
And I think this is a really interesting and important question. And my immediate reaction to it is, yeah, I think you're right to worry about it. It's part of this trajectory of almost beyond human exceptionalism, Western cultural exceptionalism. We associated consciousness with language for quite a long time, and that's clearly sort of exclusory of that's not. I mean, most people don't think that's the case anymore, but there is still this tight association of consciousness with rational thought, with System 2 thinking. And I think Yoshua is right to emphasize that we do some of these things in virtue of being conscious, but there are other aspects of consciousness, I think, that don't involve this System 2 rational, intelligent, conceptual thought. And this brings us
imagination.
Back. Well, I mean,
like imagination,
maybe creativity, but I'm thinking again, just to bring up the point about other other traditions. And of course, in the Eastern spiritual traditions, there's much more focus on the self, on the impermanence of things, and this actually is very aligned with some of the things that I was talking about earlier about basic levels of sentience and conscious awareness having to do with the self and with the body. And thinking about consciousness from that perspective, where the self is perhaps more primary and the body is more primary, might ensure us against making the same mistake over and over again of associating consciousness too univocally with things that are characteristic of Western culture.
Could I mention two things? I mean, that I think are actually practical examples, one of which I had wanted to mention before. I mean, you know, the kind of numinous consciousness that I was talking about obviously has been a focus of tremendous amounts of work and thought in other traditions. And it's kind of on the edges of Western traditions, but it's the central thing that people in, say, Buddhist traditions are most concerned with. Although, Anil, I mean, of course, the point is supposed to be to get rid of the idea of the self in those contexts. So that's a whole interesting other conversation we could have. But another one that I think is really important is the notion of care. So when we were talking about AI ethics, and we're talking about you know, what would it mean to decide whether or not an AI system is autonomous, for example, those questions are very deeply related to ideas about how you care for other creatures. The paradoxes that come, for instance, in raising, by the way, the Ted Chiang book novella is the best, beautiful example of this. The paradoxes that come from having one group of organisms that are trying to raise or shape another group of organisms such that they'll be cared for, but they'll also be capable of autonomy. That's a problem that is very much more discussed in the Chinese Confucian kind of tradition than it is in the Western tradition. And I think it's a problem that's going to come up all the time if we're thinking about some of these AI ethics issues. So if we think about our AIs as being like children, then the question is, what do we do to shape children so that they can be autonomous from us, but we can also care for them and that we can be beneficent? I think that's a really, that they can design new objective functions of their own, but new objective functions that are beneficent. Those are things that actually are more discussed in other traditions than in ours, and I think they're very essential.
Absolutely. So the answer is yes. Anil, you have to go?
I have to go. I'm so sorry. I need to be elsewhere within 2 minutes for another thing. So thank you, everybody. Really nice to see you all on the panel and in the audience. Speak again soon. Thank you very much.
See you soon, Anil. Take care.
Bye.
We're going to be wrapping up in a few minutes because also in the interest of time for all of us, and also it's the lunch break, and then we need to wrap up. So I don't know, Lucia, what do you think? Should we take just one question from those asked in the audience, because it's already close to 1 o'clock?
So
there's one question,
but it's not. He's
yeah,
not here.
There's one question I think might be of interest on emotions. We haven't talked much about emotions. So shall we maybe take that one and see what Alison and Yoshua think?
Go for it.
It says, would representations of human-like emotions be necessary for machines to reach human-like consciousness? In other words, this interrelationship between the notion of emotions and consciousness, and does that relate anywhere to the idea of integrating consciousness into machines? Do we need to take the root also of emotions? Does that come into play, or are those completely independent? We'd like to maybe hear your brief opinion on this before we end the panel.
Yeah, I think this speaks to Lucia's point before about fun. And I think there's and this point about, you know, the Cambrian explosion, that it seems like the things that might have been things like, you know, positive valence or negative valence, or approach and avoid, or what counts as being a reward, what's the signal that tells you that you should approach this, fear that. Those seem much more closely related to emotions than they do. And it's kind of ironic, right? They do actually seem to be more related to emotions than they do to the kinds of self-conscious, you know, global workspace, conceptual thought, which it's been the focus of a lot of our work in consciousness. And emotions aren't very well understood. They've been, you know, again, they've been kind of not as much of a focus of understanding. I think it's interesting to think about something like fun or curiosity as being cognitive epistemic, a kind of cognitive epistemic emotion. And as Yoshua was saying, you know, all of reinforcement learning, in a sense, depends on the idea that you have some reward that you're attempting to get, which seems much more like what's going on in a context of emotion than a context of rumination or conceptual thought.
Yeah, I completely agree. I would add that as AI is moving towards the question of how different learning agents interact, in other words, the social aspect of intelligence, I think we will have to go beyond the simple, fear or, positive, negative emotion. Human emotions are spread across a very rich palette that has to do mostly with social context.
Right.
And we haven't been studying that much in AI because we don't have societies of learning agents very much, but it's coming. So there's more and more work in that direction. And I think it'll help us develop a richer emotion-like rewards that are needed for agents that like we want to build AIs that interact with humans in society.
Yeah, I think that's a really good point.
Okay, well, Lucia, do you think we should wrap this up?
Yeah. Well, let me just, push you guys on what I was trying to tell you before. So, for instance, Joe Ledoux, when he thinks about fear, he's done beautiful work on, like the neuroanatomy of fear, right? But then in his later research, his later thoughts, he changed on how much is he really explaining fear as opposed to like the behavior of fear. And he believes that there's something that he couldn't squeeze out of that mechanism. So when I was trying to ask you about the idea of fun, and this drops up to the idea of emotions and that Karim was trying to put before, is if we have a function that say like it's a reward function, if we have fear, which is like avoidance, is that enough, or will there something else be needed, or is it something else that be understood as conscious in those machines?
So one opinion I would voice here is in reinforcement learning, typically we think of the reward function as like one function because it's usually hand designed and whatever. But it's much more plausible if you think about how it would happen in the brain, that you have very different emotions and very different sort of sources of reward. Each of them may be focusing on different aspects of what can go wrong and can be good. And somehow they get triggered depending on context, which is appropriate. So it's a much richer view of the reward function, simply not like a homogeneous black box, but something that is structured and that can even change because we can kind of adapt our reward function so we'll do better in the future.
Okay, I get what you're trying to say, is that there's the context that brings the meaning, so to speak, and in that sense, it changes it.
It's not just changing, it's also structured into little pieces that make sense by themselves.
Right. I mean, I think this is another interesting example where if you think about the very idea of reinforcement learning, the very idea of reward learning, in a sense, it's parasitic. That's the idea that that's a structure that would be effective is sort of parasitic on these examples of emotional phenomenology, right? So it's sort of taking the idea, okay, look, I know what it means when I want something and then I'm happy because I get it and I'm not happy because I don't get it. And then taking that structure, which I think really does depend. I mean, I think if we didn't have emotions that were like that, we might very well not have ended up with a functional story that was a story about reinforcement learning, just the same way that if we didn't have visual phenomenology, we wouldn't have ended up with a functional story about the color space. But then of course, it seems like we can describe that function without it's necessarily involving the emotion. But it is interesting that it turns out that something that seems to have the same structure as the phenomenology of our emotion turns out to actually also be a very effective functional tool, the same way that something that has the structure of our thinking about computation, our phenomenology of computation, sort of surprisingly turns out to be something that's extremely functional even without that phenomenology.
Mm-hmm. Cool. Well, thank you so much. I think now it's basically 1 p.m. here, and we have also people in person that are following that have their lunch break before the next, so we'll at least give them 20 minutes to get some food down before we head into the afternoon session. So I'm sure that all the audience joins us in thanking both of you, Yoshua and Alison, for your insights. This has been a fascinating discussion, and I would like to apologize sincerely to all the questions that were posed in the question and answer tab that we were not able to get to. There's just so many questions, but just proves again how interesting the topic is, and we'll surely be back with another one of these sessions in the next meetings. We had one last year, and we'll surely continue with this. We're at the very early stages, and there's so much to be done, and thank you so much for sharing your insights with us. Lucia, I'll give you the last word to Lucia.
Enjoy the lunch, have all of your emotions and be intelligent about, what you eat.
Yeah, exactly.
Thank you so much, everyone.
Bye-bye.
Bye-bye.
Yeah, we'll be back at 1:20 for everybody who's still connected. 1:20 is the next session, so it's about in 20 minutes. Thank you so much, everyone.